So let's make a review about the laboratory that happened in the previous laboratory. It's about the CNN Nature classifier, about the convolutional neural network nature classifier. This lab walks us through the complete deep learning pipeline from the prepared data to build a CNN model to train a prototype, scale to a bigger data set, and analyze results. So the problem goal. The botanical garden app now needs to classify from flowers, insects, small animals. So instead of a simple classifier, we build a convolutional neural network. So the dataset used is we use the images from the Sci-Fi 100. So each image size up to 32 by 32. Color is RGB, which means we have the three channels. Many object classes available, but we could start small. The image transformation pipelines. Images must be prepared before training. Two pipelines are used. Training transform with augmentation. Adds variation so the model generalizes better. The typical steps is random flip, random rotation, convert to tensor, normalize. This simulates new images. Validation transform. Okay, the transform, no augmentation. It only has convert to tensor, normalize. This keeps evaluation fair. Prototype data set. It has 9 classes. Instead of training on all classes, you start with 9 classes: flowers, mammals, insects. Why? Because faster training, easier debugging, quick baseline performance. Data loader creation. Data loaders load data in batches, shuffle training data, speed up training. Example, the batch size is given to 64. CNN architecture, and this is the core of the lab. Model is simple CNN. The structure is convolutional blocks for feature extractions. So the repeated pattern is from the convolutional to ReLU and pull and it's really repeated. Uh, um, the effects of it is channels increase, image width and height shrink. The example flow is from input. Um, uh, this tuple is 1, comma 3, comma 32, comma 32. After the black one, after the black one is become 1, comma 32, comma 16, comma 16. After black 2, it will become the tuple 1, comma 64, comma 8, comma 8. And after the block tree is will become it will become 1 comma 128 comma 4 comma 4. Flattening feature maps becomes a vector. So 128 by 4 by 4 will become 2048 features. And let's talk about the fully connected layers. The final layers perform classification. So the output is 1 comma number of classes, and for prototype is group 1 comma 9. So the training setups consists of two components: loss function and optimizer. So the loss function we use is cross entropy loss used for classification, and the optimizer we use is Adam optimizers. So it will updates weight efficiently. So what's the training loop all about? It repeats for each epoch. So the training phase is from forward pass, compute loss, backpropagation, update weights. Validation phase, it's evaluate accuracy and no weight updates. And we track the metrics, the training loss, the validation loss, and validation accuracy. And what's the prototype results? It the training on 9 classes works well. It's approximately 75% plus validation accuracy. Um, the model learns successful. So our architecture is correct. Scaling up to 15 classes, now trained using all 15 categories. Step repeated is load data, create data loaders, create model, train again. And the problem observed, training improves but validation gets worse. The symptoms is training loss decreases, validation loss increases, accuracy plateaus. This means Overfitting. Model memorizes training data but fails to generalize it. Why overfitting happens? Its possible causes is dataset harder, model too simple, insufficient augmentation, not enough regularization. So, what we have learned here is this lab teaches the real machine learning workflow, the deep learning workflow, from the prototype to evaluate, to scale, and fix issues. So we have learned here in this laboratory is data processing, data preprocessing, CNN architecture, training pipeline, evaluation, and debugging performance. So the key concepts to remember is the CNN flow is from image to convolutional blocks. After the convolutional blocks is flattened, and after the flatten it become linear layers, and the class scores. And training flow, um, from forward to loss to propagation and update. So scaling models requires better architecture plus regularization.